Okay, we're looking at the first year core textbook and we're on mixed exercise 8, so that's on binomial, and we're on question 3. So it's a bit nasty, but I'm hoping if we read it, it won't be too bad. It's only question 3. So 20 people play a game at school Fate, and then we're told the probability of n people winning. So if I substitute n is 2 into this, that'd be the probability that 2 people win. Okay, yeah, so this really is just, I think, a case of reading the question carefully and then having to substitute some values in. So for part A, they want 5 people winning. So n is the number of people that win, and they're telling me that p is a half. So all I need to do is go to this formula and substitute those in. So from 20, choose 5 times a half to the power of 5 times 1 minus a half to the power of 20 minus 5. So that's literally just me substituting p as a half and n is 5 into this. And then as long as you know, so that the 20 choose 5 is just going to be using your NCR button. That's above your division button on your calculator. So I'll write the values out individually, but you could just put that straight into your calculator. So 20 choose 5, I get 15,504. A half to the power of 5, well, it's just going to be 1 over 2 to the power of 5, so 1 over 32, and then obviously 1 minus a half is also just a half, so that's going to be a half. Oh, that's going to be, oh, for goodness sake, wait, get it in the end. Okay, that's going to be, so that last set of brackets is going to be 1 over 2 to the power of 15, so 3, 2, 7, 6, 8. I'm just writing them out individually so that if you're not getting the right answer, you can try and figure out where you went wrong. Okay, so I am getting 969 over 65536. So if I want to give that to 3 significant figures, I get that as 0.0148. So unlike or, I could give that as 1.48%. I'm just going to double check I've got that right. Yeah, we're good. So it's very unlikely. And if you think about it, that's because you'd expect more than 5 people to win. So the odds of, if the probability of winning is a half, obviously you wouldn't definitely get 10 people winning, but you'd expect more than 5 people to win, you would say. Okay, nobody winning if p is a 7th. Sorry, not 7th, 0.7 even. Okay, so again, I'm just going to substitute into this formula here. So now nobody winning is n is 0 and p is 0.7. So that is going to be from 20 choose 0 times 0.7 to the power of 0 times 1 minus 0.7, so 0.3 to the power of 20 minus 0, so to the power of 20. So 20 choose 0 is just going to be 1. 0.7 to the power of 0 is going to be 1. So it's basically going to be 0.3 to the power of 20. Also, that's very unlikely to happen. So that is giving me, goodness me. Yeah, let's just write that one in standard form, I think. So that is giving me 3.47 times 10 to the minus 11. And again, it makes sense that that is low, because if you've got a 0.7 chance of winning, so a 70% chance of winning, and 20 people have a go, you'd start to think something was a little bit dodgy if none of them won. So again, let's just check that answer, but it does make sense. Yeah, so 11 zeros there, I reckon there is 3, 6, 9, 10, 11, yeah. Okay, and 13 people, okay. More of the same really, isn't it? So let's get the screen back up. Okay, so 13 people winning when p is 0.6, so that is going to be from 20 choose 13 times 0.6 to the power of 13 times 1 minus 0.6 to the power of 20 minus 13. So I'm just going to put that straight into my calculator. So 20 choose 13. So that's giving me 77,520 times 0.6 to the power of 13. And at that point, I'm at 101.2465 times 0.4 to the power of 7. And that is giving me 0.166 to 3 significant figures, which is what they asked for. And yeah, brilliant, we're there.